You can't walk on water. You're too heavy, and you'll sink like a stone. But this aircraft carrier can float, even though it's over 300 meters, 1,000 feet, long, at least 1,000,000 times heavier than you are, and carries about 70 airplanes and 4,000 sailors. Ships, large ocean-going vessels, and boats, smaller ones, are a brilliant example of how science can be put to work to solve a simple problem. Over 2/3 of Earth's surface is covered in water, so it's just as well that science helps us take to the waves. How exactly do ships do their stuff? Let's take a closer look with Machinery and Technology Channel. First and foremost, a ship's heart is in the engine of the vessel. The engine's design, paired with proper fueling, provides the power for the ship's mobility and all the entertainment aboard. If you are someone who is curious about ship mechanics, this is the video for you. Where are the engines located? You guessed it. Most heavy weights, such as engines, are found as low as possible in the lower decks, ground zero. For most cruise ships, the engines are close to the keel. The structural keel is the most closest to the bottom of the vessel and the ship's wide hull. It runs the length of the vessel down its center line, and in most ships, you won't have to go far to find the engine rooms. Just because it's placed low in the ship doesn't mean it doesn't take a lot of space. For all the ship's power, the engine rooms can take up several decks high and are generally divided into several compartments. It may not feel like an open massive space, but it is truly the heart of the ship, and the design of the rooms and placement are critical. Usually, the primary concern for ships ships is have engines and machinery compartmentalized for safety and avoiding fire hazards. Compartmentalized and labeled rooms make maintenance simpler and enhances safety for unprecedented accidents. New legislations also support the requirement for compartmentalization. Ships are required to have at least a duplicate of equipment and at least 2 separate spaces for engines. So, what about these engines? Why are they so important, and why do ships need so many of them? Just to answer those questions, we'll have to visit more fundamental questions such as, how do the engines power a giant ship? How does it help the ship propel forward? Are there specific engines that power different parts of the cruise? Out of many questions regarding the engines, the answer starts with the main engines. The main engines are the engines that produce the majority of the power for the ship to move. Depending on the type of vessel, the main engine connects to different parts of the propelling power. From traditional steamboats to diesel-electric, the engine is the fundamental powerhouse for the entire ship on the sea. Diesel may be something more familiar to what we saw in old movies with steamboats. Even in modern days, we use similar mechanisms, if not labeled the same. The main difference is the source of pressure. which can be the traditional steam or a fuel ignition. Whether it is steam, traditional, or fuel ignition, the pressure generated from either push the pistons up and down in the vessel. These pistons connect to crankshafts through gears, which turns the pistons. The crankshaft connects to the propeller through a long propeller shaft and gears, which further determines its speed in traditional diesel-powered vessels by steam pressure. Generally, the faster the pistons move up and down from the pressure, the quicker the propeller shifts would move. With modern designs that control the propeller speed, engineers place the gears in between the propeller and the engines, which further enhances efficiency for both engines and propellers. Again, although the majority of the engine provides electricity to the propeller shaft, electricity must be provided to the rest of the ship for entertainment. Often, options such as a shaft generator offer power to outlets such as lighting the dining and general appliances on board while in motion. Diesel-electric. Diesel-electric is another form of vessels that are found commonly with conventional diesel vessels. Unlike the conventional diesel, diesel-electric engines are connected directly to the generators that provide the electricity for the propellers and main generators. This electricity also provides direct power for the ship's lights, appliances, and much more. On a side note, if the thought of diesel in the ocean disturbs you, there is some good news. Thankfully, more and more environmentally friendly options are appearing for cruise ships. For example, liquefied natural gas, LNG, is an alternative method for powering ships that burns natural gas for power. Why do ships float? Buoyancy is easiest to understand thinking about a submarine. It has diving planes, fins mounted on the side, and ballast tanks that it can fill with water or air to make it rise or fall as it needs to. If its tanks are completely filled with air, it's said to be positively buoyant. The tanks weigh less than an equal volume of water and make the sub float on the surface. If the tanks are partly filled with air, it's possible to make the submarine float at some middle depth of the water without either rising up or sinking down. That's called neutral buoyancy. The other option is to fill the tanks completely with water. In that case, the submarine is negatively buoyant, which means it sinks to the seabed. Now, most boats don't operate in quite the same way as submarines. They don't sink, but they don't exactly float either. A boat partly floats and partly sinks according to its own weight and how much weight it carries. The greater the total of these two weights, the lower it sits in the water. There's only so much weight a boat can carry without sinking into the water so much that it does actually sink completely. For ships to sail safely, we need to know how much weight we can put in or on them without getting anywhere near this point. About this content, let us know in the comments section below. If you have any questions or ideas, please tell us. We will definitely find out and we will explain it together.